Good morning, everyone, and thank you so much for joining us today. My name is Chanakya Lokam. I'm the Director for Marketing and Innovation at Miracle Software Systems, and I will be your host as well as speaker on today's webinar, Experience the Power of the Cloud with Amazon Web Services. A very good afternoon, good morning, or good evening to wherever you are in the world. Along with us, we also have Banu Kandregla, who is a Cloud Research Associate with our Innovation Labs team. He will also be co-speaking and giving you a live demo of the AWS platform today. So just going over the agenda that we'll be covering today, we'll quickly take you into what Miracle is and what we do as a company, along with what we do every day at our labs. We have a large research labs team, and we'll showcase back to you what we do every day there. We'll also be talking about digital transformation, along with discussing why the cloud is being adopted so rapidly nowadays with enterprises. We'll also be talking a bit about AWS and introducing it to you, along with demonstrating a quick way in which you can deploy a high availability web architecture. We'll follow that up with a Q&A session where you can ask any questions that you might have. If you do have any questions, there's two ways of asking them. You can either send them through the chat box on the right side panel, or you can also raise your hand and we'll be more than happy to unmute you so that you can ask them vocally. So moving forward, Miracle Software Systems is a global systems integrator. We're headquartered out of Novi, Michigan in the United States. We are present in about 9 locations, including the United States, Germany, India, Canada, Australia, Mexico, and many more. We have global delivery centers based out of both the US and Canada, along with large offshore development centers in India. We focus on providing affordable innovation to our customers, about which we'll be talking later in the presentation. We cover a range of industry verticals, including manufacturing and automotive, energy and utilities, logistics, healthcare, retail, and also the BFSI sector. Our strategic partnerships include us being a consulting partner with Amazon Web Services. We're also a premier business partner with IBM. We're technology services partner with SAP and a gold Oracle partner, along with being a Microsoft certified silver partner as well. At the Miracle Labs, we believe in empowering change through innovation, and that's our motto for what we do every day. We want to make sure that we can provide innovative thoughts and thought leadership to our customers. We feel that cost differentiation and labor savings are not enough for an enterprise to be competent today. And with the digital transformation era truly together, we need to make sure that innovation is provided to our customers so that we can be the disruptor instead of being disrupted. Our teams basically focus on the CAMSS trend, including cloud, analytics, mobile, social, and security. So why do we need to innovate? Well, this answer is simple. If you don't innovate and reinvent yourself today, enterprises are going to lag behind and the competition is going to take over. It's as simple as that. At Miracle, we believe that affordable luxury is what should be provided, not the lowest cost services. Innovation is very important, and we tend to provide that at low cost through our offshore delivery model along with our Innovation Labs team. So moving forward, what is digital transformation? Let's look at some of the numbers that are happening today. We have 2.5 quintillion bytes of data that are being created every day. Along with that, we have 85% of enterprises that are going to be using external cloud services moving forward. That showcases how much enterprises are looking to innovate and adopt the cloud nowadays. We're also seeing a lot of mobile explosion happening, with almost $534 billion US expected to be made in mobile transactions in 2015. We're also seeing 4.9 billion connected things today, which, according to Cisco, is going to be 50 billion by 2020. That's a lot of things. We're also seeing the API economy taking a front seat to all this digital transformation, providing that cool, loosely coupled model for integration for the cloud and on-premise applications. So moving forward towards the cloud, what exactly is the cloud? We're hearing a lot about people or enterprises moving to the cloud, running stuff in the cloud, storing in the cloud, and also accessing their services in the cloud. So what exactly is the cloud, and what does in the cloud mean? Well, nowadays, IT Infrastructure is rapidly being moved to the cloud, with enterprises looking to put their applications, services, and their data in the cloud. Some of the main reasons behind this is to reduce the IT management effort with on-premise data centers, to make sure that they're ready and available always, to make sure that they can scale whenever required, and also use the pay-as-you-go model or pay-as-you-use model to ensure that the overall TCO is reduced. Cloud also helps to provide a great range of flexibility, which helps to fuel innovation. So what are the attractions of the cloud that is attracting today's enterprises? First thing would be rapid infrastructure provisioning, which enables IT companies to scale up and down rapidly while paying only for what they use. This is a huge asset for companies that want to maintain themselves for flexible or elastic workloads. There's also a lot of movement from CapEx costs with on-premise data centers to OpEx investments with the cloud. We're also seeing a lot of flexibility being provided by the cloud, so a lot of research projects are moving into the cloud to gain greater ability for innovation. We're also seeing a lot of resource wastage being reduced with the cloud, as you only use what you need and you can turn them off whenever not required. The cloud also provides a lot of new business channels and for driving new business. So that's another major use case and attraction of the cloud. We're also seeing a lot of the hyperscale model with the mobile and social coming in, which is attracting enterprises and CIOs towards the cloud. So why isn't cloud adoption at 100% today? Why are leaders still thinking about investing in the cloud? Why aren't they just investing? Well, one of the major concerns around cloud applications and cloud data is their security. Also, integration has been predicted as one of the major challenges for enterprises that are looking to move into the cloud. Cloud integration has been kept at 42% of the challenges that people face in the cloud every day. Also, many enterprises lack a clear strategy and a roadmap and an understanding of what the ROI or TCO numbers might be if they do move into the cloud. According to the survey, 2016 cloud investments by enterprises is going to be 24% of the entire IT spend. Out of those 24%, we're seeing, as usual, software as a service being a leader, with almost 49% of that investment going into SaaS applications. We're also seeing a lot being put into the infrastructure as a service and platform as a service model as well, with almost 56% being put into those two models. So what is the hybrid compute path, or what does hybrid cloud mean? Well, today's enterprises are looking at what workloads can be put into the cloud to reduce their costs, as well as make sure that they're ready for digital transformation. Not everything is meant for the cloud. And with that, we're seeing organizations having to make decisions on what they want to put onto the cloud. There are three main models. First one would be consuming your applications and your data as a service through public clouds, which is basically the SaaS model. You can also keep your applications and data on-prem or put it in a private cloud infrastructure. We're also seeing a lot of organizations trying to move their applications and their data to a public cloud where the infrastructure is provided by them, such as Azure and AWS. So what are the decisions that are influencing where you want to put what? Where does my enterprise data and application go? Well, one thing that CIOs and infrastructure teams are looking at is the operational factors about access and how we store this particular applications and data. Also, economic factors play a major role in the decision, and security is a major factor in terms of deciding which applications or data get to go into the cloud. The cloud is for everyone. Everybody needs to adopt the cloud to be able to be ready for tomorrow's challenges. But it's not for everything. Not everything goes into the cloud. And some of the things that we're seeing move into the cloud are elastic workloads, such as back-end services that need to be available for mobile devices, where you have variable traffic increasing and decreasing every day. We're also seeing a lot of the pre-prod stages, such as test dev and pre-prod environments, being moved into the cloud, whereas the production environment still stays on-prem or in a private cloud. We're also seeing a lot of the research loads, such as loads that are being used for digital transformation initiatives or next generation initiatives. We're also seeing flexible workloads, such as systems of engagement and other systems of insight where you need to crunch huge amounts of data. Those sorts of applications and data are also moving into the cloud today. The top 5 workloads that are moving into the cloud today in 2015 start off with email and collaboration software. The main reason for this is because they're non-core workloads, and enterprises think they do not want to waste infrastructure and time on maintaining them. Dev and test workloads are also being moved to the cloud rapidly. We're also seeing elastic workloads with variable traffic, such as mobile app backend services, and also data crunching services where they need to run analytics on large amounts of data at only regular intervals. We're also seeing non-critical data, such as backup and restore data, being also put into the cloud, where access is restricted and limited. We're also seeing isolated workloads also being put into the cloud. These are workloads that work on the back end and where latency is usually not a problem. So today's webinar briefly covers AWS and the various products that AWS provides. We'll be covering most of the products in the Amazon Web Services and also be talking about how those products can be used to provide a high availability architecture for web applications. Amazon Web Services is an infrastructure as a service provider, and they have multiple products which can help in various domains, including compute, database storage, and networking. In the compute, we have the Elastic Cloud Compute instances, which basically provide us server instances whenever we need. We also have other compute options such as elastic load balancing and auto scaling, which can help us in terms of building our high availability architecture that we'll be looking at later in the webinar. In the database stage, we have a regular relational database model called RDS, along with a NoSQL model called DynamoDB. We also have caching mechanisms using Elastic Cache and a Hadoop-based model called Redshift. On the storage side, we have Amazon S3 for large file storage, as well as Amazon Glacier for redundant archiving. We also provide Elastic block storage for block storage amounts for your EC2 instances. We also provide Amazon CloudFront for your content management and content pushing mechanisms. In the networking, we have Amazon VPC, Amazon Direct Connect. You also have a DNS server called Amazon Route 53, and elastic load balancing options for your EC2 instances as well. There are a huge number of other products in the AWS category as well. If you have any questions, please visit aws.amazon.com/products. So how do you access your AWS products or your AWS instances that you have in the cloud? There's 4 different ways. The first and foremost way would be the AWS Management Console, which is a web UI where you can go in, start your instances, create new instances, and stop your running instances as well. You can also do the same through the command line interface as well, along with using Amazon's software development kits. You also have low-level HTTP requests called query APIs that can be used to access your AWS instances and products. So how does a high availability web architecture look like on Amazon Web Services? First of all, we'll start off with a quick web server, which is an Amazon EC2 instance. We'll load in maybe a Ubuntu server on this and start it running. The next thing that you'll need is a database server, a relational database server for your web applications that are running on your web server. So Amazon provides Amazon RDS for that, which you can easily connect back to your EC2 instance. The next step would be to provide it with an Elastic IP. An Elastic IP is a static IP that's not given to an instance, but it's given to an account. So if you have an organization, you can buy a number of Elastic IPs, which are static IPs. So in case your web server goes down and another web server is replaced by it, the IP still remains the same, and you don't need to remap everything. The next step would be to map your website or your web URL to your Elastic IP using Amazon Route 53, which is an inbuilt domain naming server provided by Amazon. You can also provide your EC2 instances with an EBS instance as well, which provides block storage for your EC2 instances. EBS instances provide synchronous replication so that your data and your block storage is replicated across availability zones. You can also make sure that whenever your EC2 instance goes down and is replaced by a high availability instance, again, the EBS block is removed from the original instance of EC2 and added to the next instance. We can also use elastic load balancing in Amazon to make sure that we can provide multiple servers which can take the different load. All the EC2 instances can have the same or different applications running on them, and elastic load balancing can make sure that all the load is balanced and provided and the requests are provided to the proper server or proper EC2 instance. In case of a health check and the server goes down, elastic load balancer knows which instances that are still in use and which instances to send the request to. Amazon also provides synchronous replication across availability zones, which helps them to provide database replication for RDS. RDS provides automatic synchronous replication by default for all its instances. So in case a database server or database instance of Amazon RDS goes down in one availability zone, your synchronously replicated instance in the second availability zone, which is AZB, is always available. At the same time, you can also load balance across instances where the closest availability zone will be considered as the best option for that particular request. As you can see, in case one of the servers goes down in availability zone A, you can see that immediately Amazon can use auto-scaling groups to ensure that a second instance is reborn or reinstantiated so that you can use that instance. And the load balancer also knows that this new instance has been sprung up and that needs to be used for all requests going in there. With that being said, let me hand it over to Prakash Kandrela, who will be talking more about Amazon EC2 high availability architecture, and he'll also be showing you some of the parts of the console for using high availability architectures in Amazon. Banu, it's all over to you.
Thanks, Shaniya. Thanks for well-detailed explanation on AWS high scalability web application. Hello everyone, this is Banu Kandegla, working as a research associate in Miracle Labs. Thanks for being here. Let us take you through the architecture that Chanakya has just shown below. Highly scalable web architecture. Now, before going into a demonstration about how actually we can do on AWS infrastructure, let me take back to you with a couple of definitions, what exactly elastic load balancer does and what an auto scaling is. So before getting into it, here is a console screen where Chanakya is speaking about in product set or the last presentation. All these compute, storage, databases or management tools, all these wings of AWS provide a specific services that will be most helpful in terms of SaaS. Instead of purchasing and maintaining our own infrastructure within yourself, simply pay per what you use from the cloud services, where AWS does really a great job from last pretty much years. So this is a wing of AWS from Amazon EC2 Elastic Compute Cloud, which is really a heart of Amazon Web Services. So over here we have 4 running instances. So what it's to be according to architecture, it's a simple web server that is running on AWS infrastructure. And coming back to a load balancer, what we are speaking about in highly availability. Now, what exactly load balancer is? Load balancer, also called as ELB from AWS terminology. ELB is used to automatically distribute incoming web traffic to multiple AWS instances. And ELB and EC2 will always work together hand in hand. If one particular instance from a ELB got fault rated or detached, the other instance will come up and that particular request will be transformed to the other live instance. With the help of ELB, you actually can add or remove elastic instances without distributing overall flow of an information. If one particular server got failed, ELB automatically redirect that particular request to a running instances. So in general, in a very common language, ELB can access a traffic manager for your web servers over a cluster. Now let us take you through how exactly we can create an elastic load balancer on our AWS platform and how it serves. So this is a console that how you can over here to see what exactly AWS management console is providing you. So before getting into it, go back to our instances once. And I created a couple of servers already and install a web application onto that. That helps you to understand a bit more detail how elastic load balancer works. So here is a server called test1 and it has a public IP. So what I did is I installed I hosted a sample web application on Tomcat server on these 2 instances, which actually runs a simple heading called server1, and this is a server1 instance and the other one is a server2. So now these two are a different servers which is running on AWS. So what we are trying to do is, let us create a load balancer and attach these two servers to that load balancer. Now whenever we are sending our request to particular load balancer, that load balancer will send traffic to these two servers simultaneously when which server is available at that time. So during the process, if any one server got fault rated, the request will go to another server. Go to a management console and or the left panel, you will have a load balancer. Click on it and create a load balancer. Demo load balancer, let it be our name. And HTTP is a protocol that load balancer is heading up with a port number of 80. Let us keep as a default setting for of now. Coming to security groups, it is a kind of protocols or any port number and enability of your particular request. Suppose if you want to access your server from HTTP or HTTPS or even for SSH, those security groups can be predefined to these security groups, and this security group is used to attach to particular load balancer or even to your EC2 instance. So now let us go with the default security group over here for now. Configure health check. So how actually the load balancer will communicate with the attached couple of instances. It will send a continuous signal or continuous request to this to the particular instances, and it get a response within a responsive timeout of 5 seconds or mentioned here, then it is a healthy one. And for every 30 seconds, like health check interval, which I highlighted over here, for every 30 seconds, load balancer is going to check with the attached instances whether that particular instance is healthy or not. So now according to our instances, I hosted an application on a test project. So let us be a ping path /test/index.html. So this is the test one. So we are going to attach these two servers to our load balancer. We have a panel called add EC2 instances. Just click on that. Here we'll have a list of servers which are available on this particular Singapore availability zone. Now we are working on a Singapore AZ from AWS. So now according to us, let us attach this test1 and test2 load EC2 instances to our load balancer. And this connection draining is 300 seconds. It's a minimum of average 5 minutes. So now add tags. No worries, you can just review and create it. And this is the review panel of your load balancer. You can find all this load balancer name and port configuration, everything. Let us go back and check this ping path once again. /test/index.html. Yes, it's fine. Let's create a load balancer. So now load balancer successfully created with the instances test1 and test2. You can see here. And you will check a status over here. Right now it is out of service. It takes around couple of minutes. These two servers will be in service once this particular load balancer can be able to check those pings to those instances. And this is the health check status that we configured. We can also see the traffic that load balancer is heading up with this particular cloud matrix. Right now we haven't given any request to a load balancer, so there is no monitoring enabled. So now how actually we attach these two instances to our load balancer. That was good. So now actually I can check my load balancer is working or not and my traffic is getting back to those servers or not. We'll have a DNS name for load balancer 2 as we have a public IP for each server. So this DNS name will be helpful for us to send a request to our servers. So let us copy it and paste it over here and keep in /test. But remember, still our instances are in out of service. It takes couple of minutes to go. Instead of that, we have a load balancer. Let us try refreshing it. Okay, still the instances are in service. You can see over here the status 0 of 2 instances are in service. It takes a couple of minutes when those health checks to be happen and attached to this load balancer. On the go, let this thing to be happen. And let us also check about what about auto scaling does during this meantime. So what auto scaling is, if you remember this architecture diagram over the presentation, one particular instance got failed due to this low health checks. That particular instance is replacing by another instance automatically with the help of this auto scaling group. So how actually we can implement this auto scaling example over this AWS console? Auto scaling helps you to maintain applications availability and allows you to scale your EC2 capacity up and down automatically according to your conditions you define. You can use auto scaling group either to help ensure that you are running your desired number of EC2 instances. Suppose your particular web application might need 20 to 30 servers at a time to handle a multiple set of requests. Instead of achieving that manually configuring each and every server, you'll simply make those cluster of servers and enable that into an auto scaling group. If one of that particular server got tolerated, the another will be automatically replaced in that instance. It can also help you to increase the number of EC2 instances during a demand spikes, either to maintain the performance, and it also useful to decrease even when during the lulls of your reduced cost. Let us go back to this auto scaling group panel, and you'll also find the auto scaling launch configurations panel over here. So before creating a auto scaling group, we have a concept called launch configuration. So if I want to create a 2 GB of hard disk capacity with so and so security group conditions of all the servers inside my auto scaling group, before creating an auto scaling group, I should configure that launch configuration, which defines all the specifications of the servers which are inside a scaling group. To do that, click on our auto scaling group and click on this button. We'll have an option called create launch configuration for our auto scaling group. So the first step is you should create a launch config, and then you should create an auto scaling group. Create a launch configuration. Here we have a set of AMIs, machine images, which is from AWS, and we also have a free tier servers available over here. And let us go for any one of these servers, which will help us to demonstrate how auto scaling really works. Let us pick a Ubuntu server. And as we spoke about all the various instances servers available, let us go with micro instance with CPU 1, which has a very less configurations as of now. And now let us give a sample name for a launch configuration. Sample launch config. And then over here you will have a default bootstrap script you can have to enable. But as of now we are not going with any of these ones. Click on add storage. Now all the servers which are inside my auto scaling group, we are having a 8 GB of root storage. And we even have to configure the security group for the set of servers inside our auto scaling group. Let us have our access to SSH, and then let us go with HTTP and ICMP. ICMP is Internet Control Messaging Protocol, which does a major role when you are speaking with the cloud service. Click on review and see what type of instance that we are using and what are all those properties for our instances which are in the auto scaling group, and create a launch configuration. Now it will ask for a key page to give access to all those servers. I already have a predefined key page with a name test Singapore that links with this particular availability zone. Let me acknowledge it and create this launch configuration. Now launch configuration with sample launch config is created, and soon after this configuration is done, the next step is to create a scaling group. This scaling group is attached with the specifications we mentioned inside a launch configuration. Let us also give a name for this scaling group with one particular instance. Let us go with one instance as of now, and remember one subnet should be inside one particular VPC. And now how we actually can prove that auto scaling works? We are going to do in two different ways. In general, auto scaling should work either that particular server is get terminated or tolerated, or CPU utilization of that particular server increases to certain limit either to add instances and decrease to certain limit to decrease the number of instances. So let us go with one server as of now and create a scaling policies. What this scaling policy does, we have an option called use scaling policies to adjust the capacity. Let us opt the second option. And over here we have two different scaling policies called increase a group size or even to a decrease a group size. Let us go with increasing the group size. Suppose I am creating a one particular server inside my auto scaling group, and if that particular server has a CPU utilization of more than 30. Now I will mention that as my server is taking more requests, either you can go for 80% or 90% of CPU utilization. So for a demonstration purpose, let us go with a basic value 30%, and I should insist that if my particular server has a more than 30% of CPU utilization, please add one more server to my particular auto scaling group. So what happens from the next time when the server is added, now the request from a load balancer or from a public IP will be transforming from two different servers. The same happens when my CPU utilization is below 20%. I don't want to waste a number of servers simply sitting without doing any job. So I'll remove that from my auto scaling group so that I can reduce the cost of my infrastructure. So let us try and adding a couple of instances. And for that, I'll have a options called add alarm, and I created a topic name with my mail ID. So whenever this particular server is in launch state or terminated or even with the more CPU utilization, I'll have a constant updates to my mail ID, reminding that this particular instance on this availability zone is in a launch state or isn't being terminated. And now, how would I mention that particular CPU utilization condition to this AWS? We have a value over here, either it should be a minimum value of CPU utilization or maximum or whatever. Let us go with average value of CPU utilization. We can also go with number of disk reads and writes and operations, network in or out operations. Let us go with a CPU utilization is greater than or equal to 30%. So now I'll mention here for at least one consecutive period of 5 minutes or 1 minute. So now for 1 minute, my CPU utilization of that particular server is constantly or steadily from 30 to 30 above, more than 30 to any value. Now that particular instance is got terminated, and that is to be replaced with another new server. Why it is being terminated? We started our creating auto scaling group with only one particular instance. So now I already created an alarm for this, and we have an option called this. So here it defines the same condition over here. When the policy breaches the alarm threshold, CPU utilization is greater than 30 for at most 300 seconds. For the metrics where auto scaling group name is auto scaling group that we created before, I should insist my particular server to add one server, one instance when this condition satisfies. So CPU should be greater than 30. And this is a condition I should mention, and we are not going for decreasing group size because increasing is always good than decreasing because it takes a bit more time for this. So when I insert this particular condition, it's clearly if my CPU utilization greater than 30, I should add one server and create this notification. And we have an option called add notification. When I mention it, my SNS service will be active with this particular launch configuration, and it will send a consistent mail as an update whenever my instance is in launch or fault states. We get across this already before. Now leave this off. Let us review our auto scaling group, which has a group size of 1, and it's a grace period of 300 seconds over this subnet. So the condition over here is add one instances and 300 seconds for instance warm up. So for every 300 seconds, it is going to check all my instances over the auto scaling group is working fine or not. So now let me create this auto scaling group and see actually how it works. This is my launching for auto scaling. It's creating, retrieving. Yes, it's created successfully. And quick close and see this is an auto scaling group, and inside is activity history. Now the status over here, it is launching a new EC2 instance with this following ID. So what is that instance? We started creating our auto scaling group with only one particular instance. So that instance is being created. So now let us go back to our instances panel or AWS management console and see whether that instance is being created or not. Instances. And yes, so this is an instance that is being created from an auto scaling, and this is that particular server's public IP address. So now what you do, we'll get into this server from SSH and see how actually we can increase the CPU utilization, and let us give a try whether that CPU utilization is greater than 30 for consistent of 300 seconds and that server is being added or not. Now go to my putty session. I already have a predefined session configured. Let me replace this with this present IP and click on save. And let us access this particular server from SSH using a tool called mRemoteNG. Click on save and see the status of this server is being created or not. Yes, it is in running state, but it's still having some checks. It's 2 by 2. Let us give it a try whether we can able to connect it or not. Yes, so now we can able to connect to that particular instance which was created from an auto scaling group. Let us run a sample shell script which can able to increase a CPU load of this particular server, and let us cross check our auto scaling group. So get into this root access, sudo space su hyphen, and also create a duplicate for this tab and check a CPU utilization in parallel. So the command which is used to check all these hardware configs is top. When I execute a top command, here we can see the CPU performance of this particular server is of now it's 0.3, and this is a value that we have to look at. And over a main page, let us create a simple shell script file and let us write a code which helpful to increase the CPU utilization of this particular server. So let us go with vi space, let the file name be cpload.sh, insert mode, and due to a time concern we already have a predefined code ready which can able to increase the CPU load for this server, and copy and paste it. So it simply says the same loop will repeat it all over, and whenever the CPU load is starting, this particular function will invoke, and when I press and enter, that process will be killed. So let us quick save and quick back it. And also let us change permissions to this particular file, chmod, and to this particular code that we are using to increase the CPU utilization, we should give a number of CPUs that to be added as a parameter. For this shell script, let us go with /filename.sh space. I'm giving a 2 CPUs as an input. So when I click on enter, this process will be terminated, and let us go back to our duplicate screen and check the CPU utilization. It is now heading up to 16 and then 32, 35 and 36. So if we wait for 5 more minutes where for 300 seconds, if the CPU utilization is sibling from 30 to greater than 30 to 40 in between, where this code will help us to go through. If that happens and we wait, we can observe that this particular instance over AWS is going to terminate by itself, and it is being replaced with another server, because that is the condition that we mentioned in a policies of our autoscaling group. Now, the other way that we actually can prove that autoscaling works, instead of giving this minimum time of 100 seconds, that is 300 seconds, what we can actually do is, according to a definition of autoscaling, if one particular server from autoscaling group is being terminated or fault tolerance any occurrences, that particular server will be replaced with a new server. So not only our CPU utilization conditions, we can also terminate it, and let us see whether the new server is being added up or not. So for that purpose, let us terminate this URL, this server, and see that autoscaling group is working or not. Let me highlight it and go to instance state and terminate it. So now once this particular server is being completely terminated and with a threshold value of 100 seconds, it is going to create another server when those health checks are not being enabled. So it is in shutdown state. it takes around 1 minute or 60 seconds to completely shut down this particular server. And then once the server is completely down, now the auto-scaling group will keep on checking the server which is inside a group, and it will try to communicate with those servers. And if that is not in responding state to an auto-scaling group, then it will assign another server to replace that particular position. Now it is completely terminated. And now for the first 60 seconds, the server is being terminated. And if we wait for a couple more 30 seconds, auto-scaling group will send a constant request to a rest of servers in this group. And if no one is responding back to this group, this server will insist to create or to replace with the same configuration of another server instead of this. So if you observe carefully, another server should start in next 30 seconds. Let me refresh it. Okay, so this is the launch configuration state, and this is an auto-scaling group. Coming to this activity history, this is a launching state, and these two servers. Oh, okay. So this is terminated, and according to our status, we have another one. It's launching a new instance. So once go back and cross-check our instances, it should start another instance instead of that particular server we replaced. Yes. So now this auto-scaling is working perfect. We terminated this particular instance which is in that autoscaling group. Once the consistent checks are not happening on, autoscaling group decides, okay, my particular server has some problem to launch, let us replace my server with another with the same configuration. So it go back to this launch configuration and pick all the specifications that we mentioned, and it will create a same server in replacing this particular server. So this is how the autoscaling works in a web level architecture. And remember, we are speaking about this load balancer in the beginning. Let us go back to this load balancer, and it takes time still. Let us see a different one which I created earlier and see the instances which are in service. So in general, as we saw before, they are out of service. So once this load balancer is communicating with these attached instances with continuous pings to the URL /test/index.html. Now when I enter this particular load balancer's URL in a browser with a port number default 80 as it runs on HTTP protocol and click test, see now the load balancer request is heading up to server 2 for the first time. When I refresh it, it is going back to server 1. When I do it again, it is still in a server 1. When I do it again, so it is 1, 1, 2 again. 2, 2, server 2, server 1 again. So what does it mean? This particular load balancer is taking my request and it is sending those traffic to available servers which can able to take at that particular time. So in this process, if one server might went down, the load balancer will take care of this request we are sending, and it will transform those traffic to available running instances. So this is how the load balancer and an auto-scaling group does a really a fantastic job when we are picking up a web application host on AWS infrastructure. And that is how the demonstration ends up. Chanakya, call back over to you.
Thank you so much, Banu. At this point in time, I'd like to open it up for any Q&A that anybody has. Any questions that you have, please feel free to raise your hands on the right side panel so that we can unmute you and you can ask your questions, or you can also send your questions over to us through the right side Q&A chat panel as well. Okay, looks like that should be it. So we do have a lot more presentations and webinars coming around on the cloud. The cloud season for Miracle continues. We have another webinar coming up tomorrow about connecting your SaaS applications back to your on-premise applications using a cloud integration tool called IBM Cast Iron, which is a leader in that particular SaaS integration space. We'll also be talking about another PaaS platform called IBM Bluemix and how its services or its integration services can help solve the integration challenges of the particular SaaS or PaaS applications. We'll also be talking about IBM Bluemix a bit more and how you can create scalable applications using a microservices-based messaging model on the PaaS platform on October 6th as well. So please make sure that you do attend those events. You can also visit more of our events at www.miraclesoft.com/events. And you can also check out our webinars and our on-demand recordings at /library and /webinars as well. Once again, we'd like to thank you so much for joining us today morning or afternoon in terms of discussing about cloud and why it's being adopted so rapidly across all enterprises. We hope the webinar was informational for you, and we hope you will be present at our webinars in the future as well. Thank you so much, and have a great day.